In this video, I'm just going to talk about the key concepts regarding using forces and vectors. Now, obviously, we've been used to forces acting in a horizontal and a vertical, or an X and a Y. What we're going to talk about now is forces which act in the I and the J. And when you come to do Unit 4, it will also involve the K. Now, if you want to find out more about why it's called I, J and K, I believe it's got something to do with a 19th century mathematician called Hamilton, who did a lot of work on imaginary numbers, and the I, J and K concept comes from there. Technically, it's a three-dimensional plane where I, J and K are perpendicular to each other, and we constantly have mentioned them maybe at GCSE as X, Y and Z. So in the main, we will just be using I and J in Unit 2. So to give you an example of how we'd write a force in this vector format, I could write a force as being 3I plus 4j newtons. Now in this case, 3i and 4j, you've actually got the component parts, whereas in previous questions we've wanted the horizontal and vertical. Now we've got it as terms of I and j. So if I was drawing out my force diagram, I would have 3 newtons acting in the I and 4 in the j, and I'll call my I normally as the horizontal and j as the vertical. What we could do with doing, though, is finding out the resultant force, i.e. what is actually happening and the direction of this force. And the resultant technically makes the hypotenuse of our right-angled triangle. Because if I remember, I said that I and J and K were perpendicular to each other, so we create a right-angled triangle. So to find the resultant, we can just do a Pythagorean calculation, where r squared would equal 3 squared plus 4 squared. Which, as you probably know, your Pythagorean triples, that would be the root of 9 plus 16, which is the root of 25, which means my resultant force would be 5 newtons. We'd also probably want to work out the direction of the force. So in this case, the direction to the I would be tan theta, being the opposite over the adjacent, which is 4/3. So to find theta, we'd simply do the inverse tan of 4/3. Sometimes it asks for the tan of the angle, or it asks for the angle itself. And again, this is a simple calculation because Unit 2 is in fact a calculator paper.